Okay, so just real quick, in case we forgot what imaginary numbers are. Imaginary numbers, basically, we introduce the number I is the square root of negative 1. I is the square root of negative 1. The square root of a negative, if you do that on a calculator, it says error, because calculators only deal with real numbers, okay? So for example, if I asked you for radical 25, you know that's 5. Radical negative 25, most people think, oh, it's negative 5. No, it's not. Negative 5 times negative 5 is not negative 25. It's positive 25. This is actually radical negative 1 times radical 25. Radical negative 1 is I times 5 is 5i. Okay? 5i. Right. So basically, square roots of negatives are imaginary numbers. That's what it is. Okay? And we use that in order to come up with, if I was to give you this right here, x squared equals 9, you know that has two solutions. This is second degree. And you should know what they are. 3 and negative 3. 3 squared is 9 and negative 3 squared is 9. Well, if I give you this right here, that still has two solutions. Okay? It just happens to be 3i and negative 3i. And if you remember from Algebra 2, okay, I use this analogy. If you were to ask a third grader to solve these problems, 2 times box equals 10, 3 times triangle equals 12, and 5 times circle equals 11. You know, a good third grader will say, well, that's 5. 2 times 5 is 10, and this is 4 because 3 times 4 is 12. A smart third grader is going to go 5 times, you can't times 5 by something to get 11. And yes, you can. They just don't know about decimals and fractions yet, okay? That has solutions. They just don't know about them yet, okay? This has two solutions. They just happen to be imaginary numbers, okay? So, if you haven't taken any notes, I mean, most of this you've been taught. You might have forgotten it, though, so if you haven't written anything down, I'd at least write this down and also write down what I squared is. I is the square root of negative 1. Do you guys remember what I squared is? Well, we square this, so you square this. When you square the square root of negative 1 squared, remember these things cancel each other out, so you get negative 1. I squared is negative 1. Okay? You definitely need to know those things, okay? All right, let's dive into the assignment, okay? Okay. It says, write an expression in the form a plus bi, where a and b are real numbers, okay? So, they give us, this should be, I'm not even going to write this problem down. We're just going to add the real parts and add the imaginary parts. That's all you're doing. So we're going to add 5 and negative 3. We're going to get 2. We're going to add negative 2i and positive 6i. We're going to get positive 4i. Okay? That's all we're doing. It's kind of like adding like terms, but they're not terms. They're adding real numbers and imaginary numbers. Why did I put a there? How about we do number 3? Okay? Okay, I am going to write this one out. 7 minus 6i. This is a little bit trickier. Just a little bit. Negative 11 minus 3i. Okay? So, I'm going to take 7 and I'm going to minus the real part, positive, or the real number 7 minus 11, minus is plus, so it's 18. And I'm going to take the imaginary parts, negative 6i minus 3i, minus, plus, so it's really negative 6 and positive 3, which is a negative 3i. And when you're writing it, I don't know if I taught you this in Algebra 2. I may not have. When you write it, it's going to be in the form a plus bi. That's what it says on the top of your assignment there, at the top of the instructions, okay? This is what's called a complex number. A complex number, you take the real numbers, you take the imaginary numbers, you put them together, that's what's called the complex numbers, okay? A complex number has two parts, a real part and an imaginary part. That's the real part, easy way to remember it. It's not imaginary, it doesn't have an I. That's the imaginary part. Why is that imaginary? It has an I. It's imaginary, okay? You always put the real part, that's just the way you're supposed to do it, okay? You put the real part, then you put the imaginary part. Number 5. Okay, so we have 3 plus 5i times 2 minus 7i. Okay, so we're going to FOIL this one out. 3 times 2 is 6. Our outers are 3 times negative 7, that's negative 21i. Our inners are 2 times 5i, that's 10i. If we're going to make a mistake, here it is. We do our last, 5i times negative 7i is not negative 35i. It's negative 35, what? I times I is I squared. That makes a big difference, okay? Because what is I squared? Negative 1. So we have negative 35 times negative 1, which is a positive 35, Okay, I'm going to put in parentheses right here. That's a positive 35. So we put together 6 and 35, and we get 41. Put together negative 21i, positive 10i, that's negative 11i. Okay? Your answer will drastically change if you would have just put an I right here. If you would have just said, because then that's imaginary. This, and then you put this, this, and this together. You only put these two together, you put this with that. Okay? So don't forget the I times I is I squared. 7. 1 minus 3i. I'm going to shut my mouth on this one for about a minute. Go ahead and try this one. Do this one the same way. 2 plus 5i. Go ahead and FOIL this thing out, see what you get. You can answer? 17 minus I? Okay. Your first have been 1 times 2. Your outers is 5i times 1, which is 5i. Your inners are 2 times negative 3i is negative 6i. And your last, 5i times negative 3i is negative 15i squared. Remember, I squared is negative 1, which makes that positive 15. 15 and 2 is 17. 5 and negative 6 is negative 1i. So 17 minus 1i. Big question on that one. You're just foiling. You're foiling and remembering that I squared is negative 1. Number 9. 5 minus 2i squared. We've talked about this a few times. We don't just square both those. That's not the way you do it. When you square something, you times it by itself. So it's 5 minus 2i times 5 minus 2i. Then it's the same problem we just did. Okay? So if we FOIL this thing out, we're going to get our firsts. Our 5 times 5 is 25. Our outers, I'm going to skip a step here. My outers are negative 10i. My inners are also negative 10i. Together, that's a negative 20i. And our last, negative 2i times negative 2i is a positive 4i squared. Well, I squared is negative 1, which turns that into negative 4. Put together negative 4 and 25.
So why don't we skip the middle bit, so how we got 20i? Couldn't you skip the end bit and just write negative 4?
You definitely could. And I'll tell you what, should you skip steps, I mean, like, I don't care who you are, I don't care how smart you are, the more steps you skip, the more likely you're going to make a mistake. So I got to be able to see your work, but just be careful. You skip too many steps, chances are you're going to make a mistake. So, and I skipped a step too. I mean, I'm not saying you have to show every single teeny tiny step, but just be careful. Okay, number 11. Okay, this one's a little different. So we have I, and it says 3 plus 4i squared. Well, I'm not going to write 3 plus 4i squared. I'm going to 3 plus 4i times 3 plus 4i. So you guys remember this from Algebra 2. How do you multiply 3 things together at the same time? You can't. It's impossible. Okay? I don't care how smart you are. I don't care if it's the fastest computer in the world. It can't multiply 3 things at once. It's impossible. You only do 2 at a time. I'm going to do these 2 first. It doesn't matter. It really doesn't matter which ones you do first. Okay? So if we do that, we FOIL this out, we're going to get 9. Okay, I'm going to skip a step here. My outers is 12i, my inners is 12i, that's 24i. Okay, and I'm going to do what Jonathan said, okay? If you struggle with this, if you can't see it, then don't skip this step. But he's able to say, well, 4i times 4i is 16i squared. Well, 16i squared is negative 16, okay? Let's put together 9 and negative 16. That's a negative 7 plus 24i. Plus you. We all done?
Oh, yeah, we're done.
Now we got to multiply by I still. I times negative 7 is negative 7i. And what's I times 24i?
24i squared.
Which is what? I'll write 24i squared.
Negative 24.
Which is negative 24. So we have negative 7i minus 24. I probably wouldn't mark you wrong if you did that. I should take a point off if it was a test. I mean, what's wrong with my answer?
The 24 has to be. It's real.
Why?
Real number.
Reals come first. That's just the way you do it, okay? Just like if I say, what's x times 2? You don't say x2, you say 2x, because that's the way you say it, okay? It really should be negative 24 minus 7i. Real part's supposed to go first. Hopefully this isn't too bad yet. Okay, number 13. This one right here. Bless you. You might be thinking, this is no different. We've been doing this. Shortcut here, though, these are conjugates. Remember, conjugates are almost opposites. They're almost opposites, okay? Opposites, the opposite of positive 3 plus 4i would have been negative 3 minus 4i. That's the opposite. The conjugate is they're the same except that you change just the symbol in between. If you remember, when you're multiplying conjugates, you don't have to do all of FOIL. You just have to do your first and your last because your outers and inners cancel. Now, if you're sitting there, I'm going to forget that, then FOIL it out. I don't care. But you're going to find that your outers and inners are going to cancel because they're conjugates. I'm going to do my first. 3 times 3 is 9. My last, 4i times negative 4i, is negative 16i squared. I'm going to write that down. I squared is negative 1, which changes that to positive 16. That's interesting. So we took an imaginary number times an imaginary number and ended up with what? A real number. It's kind of interesting. 15. Okay. Listen carefully when you get to number 15. There's only 2 questions like this, 15 and 17, okay? Well, I'm going to do 15 and 17 with you guys. There's 2 parts to each of them, though. This is a little bit tricky. Once you get it, it's a piece of cake. It's a really, really simple problem. We've never talked about this. We look at part A. It says I to the 43rd power. What the heck is I to the 43rd power? Again, we never talked about this in Algebra 2, okay? What you need to understand is the powers of I is cyclical. What I mean is this. You may think I'm talking totally off topic here. I'm not. This is totally on topic. What day of the week is it going to be 7 days from now? Tuesday. How about 70 days from now?
Tuesday.
Do you know what the date is going to be?
No.
Me neither, but I know it's going to be a Tuesday. How do you know it's a Tuesday?
The 70 is a multiple of 7.
A multiple of 7. Every multiple of 7. I'm going to tell you right now, 84 is a multiple of 7. So 84 days from now, it's going to be a Tuesday. I have no idea what the date is, okay? But it's going to be a Tuesday, okay? Now, try this one, okay? Any idea what day of the week it's going to be 7,001 days from now?
Thursday.
Huh?
Thursday.
7,001 day from now. Wednesday, why?
Oh, because it's Wednesday.
Right. Now, what matters is not that it goes, how many times it goes into it. What matters is what's left over, okay? So let's do this one. This might be a little bit tougher. What day of the week is it going to be 20 days from now? 20 days from now. Monday. How did you do that?